Hello class, today we'll be talking about 8.5 annuities, methods of saving and investments. So in this section we are going to determine the value of an annuity. We're going to determine the regular annuity payments needed to achieve a financial goal. Always keep in mind that you can always pause or rewind this video. So, annuities. An annuity is a sequence of equal payments made at an equal time period. The value of an annuity is the sum of all deposits plus all interest paid. First example of determining the value of an annuity. It says you deposit $1,000 into a savings plan at the end of each year for 3 years. The interest rate is 8% per year compounded annually. The first thing says, A says, find the value of the annuity after 3 years. B says, find the interest. So the first thing we have to look at is the value of each thing per year. So let's look at this thing. So at the end of the first year, so if we say year one, so in year one, we know that we put in $1,000. After year two, we know that we have that $1,000 times 1 plus 0.08. Now, if you think about it, that's just your future value formula. Then we know that we added another 1,000 at the end of that year. So when we do that, we should get what? We multiply that, so it's going to be $1,080. Then we got plus 1,000, the 1,000 that we put in, and we end up with $2,080. That's after the first year because we're putting all our numbers. So year three, all right, we know that we have to use what we have, which is the $2,080. Then we use the future value formula again. We do 1 plus 0.08, because that's 8%. Then it's plus that $1,000 we put at the end of the year still. So this will equal $2,246.40. Then we add our 1,000 to it. And that'll be what? $3,246.60. So just keep that in mind. So in this type of problem, you have to go year by year basis. So the T is just 1. So remember, the future value formula was A is equal to P times 1 plus RT. And since you're going by year basis, your T will just equal 1. And your principal is what it is when you start off the year. Now, to find the interest, which is part B, we know each year we put in $1,000 ourselves. So if we look at that, that's what? $3,000 for 3 years. Now we have to look at what we earned, which was what? 3,000. So this is what we put in, which is the 3,000. So what we deposited. The 3,240 $46.60 is what we ended up with. All right. So now to get to figure out what the interest is, all we got to do is subtract. So it'll be $3,246.60 minus our 3,000. And we see that that should give us $246.40. So that's how much interest that was accrued over that time period. So make sure if you have any questions or anything, you make sure you either email me or you do what? You can send an email right through OneNote. So let's look at the annuity interest compounded in times per year. It says if P is deposited, if P is the deposit made at the end of each compounded period for an annuity that pays an annual interest rate R in decimal form, of course, compounded in times per year with the value A of the annuity after T years is, so let's look at this formula. We have A is equal to P, parentheses, plus 1 plus R over N raised to the NT minus 1, close your bracket, all over R over N. So you got to make sure when you put this in the calculator, you put exactly the amount of parentheses that you see. Because if you don't, you will get this wrong. So my thought is make sure you put parentheses around the denominator as well. All right, let's go ahead and look at an example of doing the annuities. It says to save for retirement, you decide to deposit $1,000 in an IRA at the end of each year for the next 30 years. You can count on an interest of 10% per year compounded annually. It says how much would you have from the IRA after 30 years, and then it says find the interest. So now we want to do what? We want to go ahead and put what we have. Remember the formula is A is equal to P times 1 plus R over N raised to the NT minus 1, close your parentheses, all over R over N. So when we look at this problem, we're going to do what? We're going to plug in what we have. So, like I told you during class, we're going to say what our P is, our R is, our T is, and our N is. We're looking for A. So our P in this case would be 1,000, because that's what we start off with. Our R would be what? 0.10, all right, because it's 10%. Our T in this case would be what? 30 years. And our N in this case would be 1 because it's compounded annually. So let's go ahead and plug all this stuff in. So we have A is equal to 1,000 times 1 plus. Now, if we know our N is 1, we don't have to put that in because anything divided by 1 is itself. So it's going to be our 0.10. Then we're going to raise that to the what? NT, so it's 1 times 30, which is 30. Then it's minus 1 Then you close your bracket. And now it's all over just your R, which is 0.10. So when you stick that in the calculator, make sure you stick it in exactly the way you see it. Then you'll get $164,494. All right. So now we're looking at, this is the total amount that you will have after the 30 years. But Part B wants you to figure out what? Part B wants you to figure out the amount of interest that you accrue. So therefore, now it's basically the $164,494 minus the 30 years times the $1,000 because you did $1,000 per year. So would that be $30,000, of course? And you should end up with $134,494. So that interest is nearly 4.5 times the amount of your payments. That's how much interest that you gain, which is pretty good, considering. All right, let's look at another example. It says at age 25, to save for retirement, you decide to deposit $200 in a IRA at the end of each year, at the end of each month, at an interest rate of 7.5% per year, compounded monthly. How much will you have from an IRA with it when you retire at 65? So this is an interesting type of question. So we basically need to take out and see what we actually have. So we know that what? We're gonna write our P, our R, our N, our T. So our P would be $200. Our R would be 0.075. Our N is compounded monthly, so it's 12. And then the T, all you gotta do is do what? The T is what? 40, right? Because all you gotta do is subtract what? 65 minus 25. And that should give you 40. So that's your T. So now, as we plug this in, we got A is equal to 200, bracket, parentheses, 1 plus your 0.075 over your what? Your N, which is 12, raised to the NT, so it's going to be 12 times 40, which should give you 480. So we'll just go ahead and multiply that and put that up there. Then it's minus your 1, close your bracket, all over your 0.075 divided by 12. Now, when we stick this in the calculator, we should get $604,765. It's a good little chunk of change, right? So now for part B, we want to find out what type of interest did we accrue. So to figure that out, we just do the $604,765. Then we subtract the 200 times 12 times 40. Then we should get what? We will wind up getting 604,765 minus our 96,000, and then that equals 508,765. $765. Not too bad. I think the person can live off of that if they retire and they keep their money and they keep it invested. So make sure if you did not get this answer when you stuck it in the calculator, make sure you relook at and make sure you put your parentheses where they're needed. And if you have any questions about the way to put it in the calculator or whatever else, just ask me. I can always show you a demonstration on how to put it in the calculator. Now, planning for the future with an annuity. The deposit P that must be made at the end of each year, each compounding period, into an annuity that pays an annual interest rate R in decimal form, compound n times per year in order to achieve a value A dollars after T years. So instead of looking for the annuity, we're looking for the amount that you need to actually be investing. So this is basically saying after it's trying to figure, it gives you where you're trying to go, and now you're just doing what? You're trying to figure out what you need to be investing each year. So if you look at the problem, is P is equal to A times R over N, all over bracket, parentheses 1 plus R over N raised to the NT minus 1, close your bracket. Keep in mind that these slides can be, stopped at any time, so you can do what? You can make sure you can copy all the notes. All right. It says, suppose once you complete your college education, you begin working, you would like to save $20,000 over 5 years to use for a down payment for a home, anticipating a regular end-of-month deposit in an annuity that pays 6% compounded monthly. How much should you deposit each month? That's part A. How much of the $20,000 down payment comes from the deposit, and how much comes from the interest? So the first thing we need to do is go ahead and write everything that we have. So in this case, we have an A, and we got R, N, and T. We're looking for P. So your A in this case would be what? Your $20,000. Your R would be 0.06. Your N is number of times compounded, so that'd be what? 12 because it's monthly. And then your T would be 5 because it's 5 years. So now we have P is equal to your 20,000 times your R over N, which is your 0.06 over your 12. Then we have all over bracket 1 plus 0.06 over 12. And don't forget your parentheses right here. Raised to the 12 times 5, which is what? 60. Then we have minus 1, and then we close our bracket. So when we plug everything in, we should get P is roughly about $287. So now for part B, we're looking at the total deposits. We're looking at how much of the $20,000 is a down payment from the deposits and how much comes from the interest. So if we look at part B, we have total deposits is equal to $287 times your 12 times your 5, which is equal to $17,220. Now, interest is equal to your $20,000 minus the $17,220. Then we put that in the calculator, you get $2780. So we find out the total deposits and we find out the amount of interest that will be accrued or that will be paid. Okay, make sure if you have any questions about 8.5, you make sure you email me or make sure you send a question through OneNote.